All right, Math 1, we are going to begin the last section of Chapter 2, Arithmetic Sequences. It's on page 146. So if you want to turn to that and go through some of these terms with me here. And the first one is a sequence. And what a sequence is, it is an ordered list of numbers that often form a pattern. So you figure out the pattern, and then you can continue that pattern. And each number in the list is reflects to a term in the sequence. So for an example, this is the first term, second term, third term, fourth term. All right, so what's going on in this pattern? If we look at it, it looks to me like we're adding 6. So to get the next two terms, you just finish adding 6 for the two terms. Here you have an option. You can either say you're dividing by 2 or multiplying by a half. I chose to say that one. So you take 50 times a half is 25. 25 times a half is 12.5. I'm not going to go through page 147. If you want to go through that, that is fine, but I feel like this should be pretty easy for you. Okay, over on page 148, we're going to get into really what the section is about, and it is about arithmetic sequences. All right, and an arithmetic sequence has a difference between consecutive terms. Consecutive means one term to the next. That is a common difference. That means you have to be adding the same thing to each term to get to the next one. So you either have to be adding or subtracting, but I will always say adding. So you're adding a negative or adding a positive, but it has to be the same thing. You can't be adding 4, adding 5, adding 6, adding 7 to get to the next one. You have to be adding a common difference, common meaning the same thing. So you have to be continuously adding 4 to everything, something like that. So here it says tell whether the sequence is arithmetic. So you look and you say, well, how do I get from an 8 to a 15? You're adding 7. Here you're adding 7 again, but here you're adding 8. Because you're adding a different number, it is no longer an arithmetic sequence. You come over here, how do I get from here to here? You're adding 2, adding 2, adding 2. So yes, CD stands for common difference. So the common difference is equal to 2. Here you're adding a -6, here you're adding a -6, here you're adding a -6, which means yes, it is an arithmetic sequence, and the common difference is -6. All right, this one here, if it alternates signs going like that, you definitely know it's not an arithmetic sequence. The only way to get from here to here is by multiplying by a negative, and multiplication does not warrant an arithmetic sequence. That's something for another day. So if you're ever multiplying, it is not arithmetic, and you have to be adding, and it has to be a like term all the way through. So if I look here, it looks to me like we're adding a 14. Here we're adding 12. Right there is no longer arithmetic sequence. Now, if you come to something and you can't figure out what you're adding to get from one term to the next, you can always subtract. Take 14.5 minus 15 or 14 minus that. So any way you look at it right here, it is an arithmetic sequence. You're adding a -1/2. You're going down by a half every time. So yes, it's an arithmetic, and you're adding a half, -1/2. All right, top of page 149, you're going to have two different kind of formulas that you're going to have to memorize. You have the recursive formula, which in my opinion is not really that useful. It's useful if they give it to you, you can write the sequence, but if I can't ask you, like, what's the 50th term in the sequence using the recursive formula? So what the recursive formula is, it basically shows you how to get you're getting from one term to the next. It just gives you your common difference, more or less. So here's your sequence. If you look, it is an arithmetic sequence. You're adding, on here, you're adding 4, you're adding 4, you're adding 4. All right, so here's the recursive formula based off of that sequence. The A sub n, A of n is the term you're looking for. So if I wanted the 10th term, so A of 10, you would take the term before, which is 10 minus 1, so the 9th term, and you would add 4 to it. All right, so what I'm getting out of this right now is that the common difference to get from one term to the next is you are adding 4. So the problem with that is there are infinite amount of sequences that add 4. So if I started with 6, I could add 4, and here's the sequence that's adding 4. It's completely different than the sequence above, but it is a sequence and where the common difference is 4. Same thing here. I could start with a -2 and add 4. Here I could start with a 1 and add 4. So as you can see, we have infinite amount where we're adding 4, which is why on the recursive, you have to put this little bit in, which says where the first term, A of 1, the first term is 7. Tells me I'm starting at 7, adding 4. So 7, 11, 15, 19, etc. All right, so here's your recursive formula generic. You would say to get to a term, you take the term before it and you add the common difference, but you have to add in where the first term is whatever. All right, so if I'm looking here, this is your arithmetic sequence. We're adding 6, adding 6, adding 6. So the recursive formula would be a of n equals the term before it plus 6. Sorry, that's a 6. Where the first term is 3. We're starting with the 3 in the term. All right, but now it's asking for the 9th term of the sequence. Well, right now I have the 1st, the 2nd, the 3rd, and the 4th. So I can't really use this formula to find the 9th term. I just have to continue the pattern until I get to my 9th term. So if I add 6 to this, I'm going to get 27. I add 6 to that, I get 33. If I add 6 to that, I get 39. If I add 6 to that, I get 45. And if I add 6 to that, I get 51. So here's 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. Here's my 9th term. So the way I write that is I would say a of 9, which is the 9th term, is 51. So here is my recursive formula. Here is the 9th term. This is just showing my work. All right, so coming here, let's see if this is an arithmetic sequence. So to get from here to here, it looks like we added 12. All right, to get from here to here, it looks like we added 12 again. Here to here, added 12. All right, so the recursive formula, you always start out like this. You would take the term before, and you're adding the common difference, which is 12. But then you have to put this little bit here where the first term, I look back, the first term is 23. Okay, and then to get to the 9th term, we would sit here and keep adding 12 until we get to the 9th term. It looks like here we're adding 5/10 to get to it. So your arithmetic sequence, excuse me, your arithmetic sequence, whoops, would be a sub n. Take the term before it, and you're adding 5/10 to it to get there. If I add in 5/10, adding 5/10, but then you have to again put this where the first term is 7.3. And then again, to get to your 9th term, you would just keep adding 0.5 to it until you get to, you can say a sub 9 equals whatever it does. Okay, if none of these were subtraction, but if any of these were subtraction, you would just either put like plus negative 12 or minus 12, whichever you want. I kind of like the plus negative, or put parentheses or something around that, I guess. Here, let's do D actually on the next page here. So here we are going down. If you take a look at D, it looks like we are subtracting 9. All right, so your sequence would look something like this. Okay, so to get to this term, you take the term before it and you subtract 9, and then you'll put where a sub 1 equals, what is our first term? 97. And then you would continue with this pattern to get the 9th term, and I believe it's 25. Okay, so check my math, go through and just keep subtracting 9 from that and get to your 9th term, and you should have 25. Okay, here's the explicit formula, which is a lot more useful and the one we will use mostly. Here's what this says. To get to the term you are being asked, literally you will put the first term in right here. So you will enter in the first term. This is the term I'm asking for, and then this is your common difference. All right, so all you're going to do is follow this formula along. The usefulness of this is I can ask you any term. So if I have this, I can ask you, like, what is the 250th term? And you do not have to write out to the 250th term. You just literally plug the numbers in and you get your answer. Okay, let's come back to the word problems over on page 151 later. Let's deal a little bit with the explicit formula first. Okay. All right, so I'm on page 152, and what we're going to be doing is writing the explicit formula from the recursive. All right, so your explicit formula, okay, looks like this. I'm going to write it here because since it's on the other page. All right, and you don't have to like write where anything is because you're given the first term right here. All right, so this right here, if you remember, is our recursive formula. So what is it saying is this right here is your common difference, and this right here is our first term. All right, so to write this, you will write a sub n to get your explicit, a sub n. I'm going to input my first term. Well, my first term, I was told, is 21, so I'm going to put 21 right here. Then you write n minus 1, and you're going to input the common difference right here, and your common difference is 2. I don't know why they put it at the back end of it, but that's just what they do. All right, so I believe that is all they want on that one. They just wanted you to write it into the explicit form. All right, so why don't you give part B a chance. Remember, this is your common difference. This is your first term. All you're doing is putting it into the explicit. All right, and then check your answer with mine. All right. You don't have to, I don't know why I put parentheses there. You do not have to do that. I feel like it looks a little better. Sometimes I do, sometimes I don't. Especially if this is a negative, because then kids get lost. Are we subtracting 7 or are we multiplying by a negative 7? This is a multiplication. So maybe the parentheses would be good for that. Same thing down here. This is your common difference, first term, common difference, first term. All right, the top of page 153. This one right here, I know, is the explicit formula. Here's the first term, here's your common difference. And for each explicit formula, find the recursive formula that represents the same sequence. So the recursive formula, if you remember, you write a sub n equals a sub n minus 1 plus your common difference, and then you write where the first term is whatever. Okay, so this is what we're trying to write out of this. So remember, this is our first term, this is our common difference. All right, so you'll write this is your recursive formula. All right, now I'm ready to input my common difference. To get from one term to the next, I'm adding 10, and then you will write where the first term in this sequence is 76. All right, so you can try those, see how you do. Okay, let's go through a few other examples that you are going to need for your homework. All right. All right, so I'm just going to use this as just as a note page for you, so I'm crossing this off. Give the explicit formula for, okay. I'm going to give you, you're going to have a worksheet I'm going to upload, and some of the problems are not like the examples that are here. So I'm going to just go ahead and make something up. All right, so here will be in a sequence right here. So it says, give the explicit formula for this sequence. Find the common difference in the first 5 terms. All right, so this is just by glancing at it, it does not look like an explicit or a recursive. Definitely not recursive because I don't see the words where. So this really is a simplified version of the explicit formula. So the first thing I would probably do is just go through and input the number 1. So you're gonna go put the number 1 here to get the first term. So I'm gonna put a 1 in for n. 14 plus 2, because 2 times 1 is 2, gives me 16. That means my first term is 16. All right, then I'm going to input for the second term. I'm going to put a 2 here. So 2 times 2 is 4. Well, what's 14 plus 4? 18. And if I want to, I think I have the pattern already, but let's go and just double check. Let's put a 3 in here. If I put a 3 in here, I'm going to get 6, and 14 plus 6 is 20. So there was more than I needed, because I need to find out what's going, this are my terms. So the pattern is 16, 18, 20 without plugging in. I know the fourth term is going to be 22, 24, etc. So the common difference, it looks to me, is like 2, and I am beginning my first term here. So if I write the explicit formula, I will write a sub n. My first term goes here, and you just have to have these memorized. So write the recursive and the explicit formula on a note card for right now, so you can keep referring back to it. then you will literally write n minus 1 times the common difference. Well, the common difference is a 2. So here is the explicit formula. And then it asks you to find the common difference. Well, the common difference is 2. Then it asks to list the first 5 terms. Well, I already have, well, here, I have the first 5 terms, I guess. So then as an answer, I would write 16, 18, 20, 22, 24, and those are the first 1, 2, 3, 4, 5, the first 5 terms. All right, so that's how you're going to do that one. All right, so let me give you another one and you just give it a try. So we have a sub n equals negative 3 plus 6n. All right, so the directions will be the same. It will say give the explicit formula for the arithmetic sequence, find the common difference in the first 5 terms. So what I would probably do is find your first term by sticking a 1 in for n. That gives me 6, and 6 plus negative 3 is 3. All right, take the second one, plug in a 2 here. That gives me 12. 12 plus a negative 3 is 9. So now I found my common difference. So to do that, you're going to write a sub n for the explicit term. First term was 3 plus n minus 1. And then you're going to multiply by your common difference, which in this case is a 6. If it was going the other way, it would be a negative 6. It wants to know your common difference. Well, your common difference is 6. The first 5 terms, so we have 9, and we're just adding 6. So 9 plus 6 is 15. 15 plus 6 is 21. 21 plus 6 is 27. All right. So you should be fine on that part of the worksheet. Okay, I'm just flipping this over so I can have some room to write. Then you're going to have some on your worksheet that say, given the first term and the common difference, find the term named in the problem and then write the explicit formula. So I will say it again. So they're giving us the first term. Then they're going to give us the common difference. All right, so we're going to say the common difference is 4. So first term, adding 4. What they're going to ask us to do is to find the term that's named in the problem. So what you're going to see is a of like 51. That means I need to find the 51st one. Now, I don't know about you, but I'm not going to write a 7 and keep adding 4 until I get to the 51st term. That's a little tedious. So what I'm going to do is write my explicit formula first, use it to find my 51st term. So to find the recursive formula, all right, you have to write it anyway, so make sure you put an n here because it's just the generic formula. The first term goes next, which is 7, plus n minus 1 times your common difference. All right, so here's my explicit. To find the 51st term, you're going to use this. So I want a of 51. That's what this is. So I'm going to put 51 in here. So 51 minus 1 is 50. 50 times 4 is 200. Well, 200 plus 7 is 207, which means my 51st term is 207. All right, let's try another one. So first term, let's say, is negative 2, and we have a difference of negative 4. So, and I'm going to ask you to find the 42nd term. All right, so write your recursive or your explicit formula first. So write a sub n, first term, negative 2 plus n minus 1 times your common difference of negative 4. All right, so to find your 42nd term, what you're going to do is stick 42 in place of the n. All right, so you're going to stick 42 here, which means I stick 42 here. So to do my math, what I do is put 42 here. 42 minus 1 is 41. So take 41 times the common difference, which is negative 4. So take 41 times negative 4, then plus negative 2. All right, and I think we should get negative 166. All right, since this formula is going down, you're subtracting 4 from it. So like a term would be -2, the next one would be -6, then -10, then -14, -18. That's what our term is. So it makes sense that my 42nd term would be -166 deep into the negatives because you're subtracting 4 to get from term to term. So let me make sure you realize this is the explicit formula. You leave it with an N and you leave it with an N here. To find the term that's being asked, you input 42nd here, but when I put a 42 in here, you subtract 1 from it. Then you do your multiplication first, then you do your addition. Follow your order of operations with that. And that should get you through your worksheet. If you have any questions, just let me know.